Hi, this second challenge I'm posing is going to be surrounding palindromes, the idea being to practice a few different techniques which are covered in videos 7, 8 and 9 in my playlist, and of course videos before that. But in particular I'm focusing on constructing basic conditions, doing some string slicing, using selection and using a couple of built-in functions as well. So to do this challenge you need to know these topics. So in this task, in this challenge, I want you to be able to write a program which allows a user to enter some text, and then this program is going to reverse that text and print it back to the screen. So for instance, hello would become olleh because that is the reverse. So that's the first stage of this program. The second stage is where the palindromes come in. So this should also check if the text is a palindrome. And a palindrome is where we have the text which is the same forwards as it is backwards. So racecar and kayak are both palindromes. If you look at those two words, if you flipped it around, if you reversed it, it's the same word, and so that's what a palindrome is. Hello isn't a palindrome because hello is not the same as olleh. So you can also have, once you remove punctuation and spaces, you can also have phrases which are palindromes. So for example, do geese see God? If you get rid of those spaces and punctuation and make it lowercase, this will also be a palindrome as well. So that is my core task for you in sort of two stages. The second stage does rely on the first stage. To help you do this, here are some success criteria. So it should be some user input. We should check to see if this input is longer than 2 characters. We want to use variables with meaningful names. We want to use an operation to reverse the input, use print and keep the user in communication with the program so they know what's going on. Use if statements with a condition, use else as well, and have 2 comments at least to explain what's happening. And if you'd like a bit more challenge, I've written some extension criteria as well. The first 2 are not covered by any of my videos. I haven't shown you how to do this so far, which is quite cheeky, me then asking you to try and do it. But actually a lot of programming is trying things and researching and, you know, going beyond what you know already. So the first one is trying to get your code to work on phrases and not just words. So like do geese see God, by removing spaces and also punctuation. And secondly, see if you can detect if his input is just numbers or letters, and then use that in your output. So for example, 1 2 3 2 1 is a palindrome. It's the same forwards as it is backwards, but it's also a palindrome number. So try and distinguish between it being a palindrome number and a palindrome string. There are a few ways of doing the second one in particular. The third one is about writing a function which sort of contains your key code here, which I won't show you how to do that because it'll be covered by a future video. But if you do know how to do it, it's a good chance to practice that skill as well. So now I'd recommend you pause on one of these slides and have a go at this yourself. I'll now show you a solution. If you want to just skip to the solution, you can have a look in the description for a link, but yours may well be different to mine. Okay, right, so I'm in Replit, which is how I'm going to code this solution. And I've copied and pasted my criteria in just to make things a bit simpler. So we could just have a variable called text, set this to the input. So we want some input from a user, we could just say enter some text here. It doesn't need to be a complicated program here. Let's add a space at the end of this so we have that gap before the user enters it. And now I say I want to have a check to see if this input is longer than 2 characters. Now this is, well, I suppose, but when we do look at loops in future videos, this is a slightly better way of doing it. But here we can use an if statement. So an if statement is for selection. Here we are doing some decision, some selection between whether this input is longer than 2 characters or shorter than 2 characters. So we want a condition after our if keyword. We want to see if this text is longer than 2 characters. So we need to use a built-in function called len to find the length of this text string. And then we want this to be greater than 2, like so. Then do our colon, press enter, and now we're going to put our main code here. If it's not longer than 2, we could, you know, just tell the user it should be longer 2 characters, and then the program's going to end at that point. Now, if we had a loop, we wouldn't just end the program, we could just get them to input it again. So, we can now put our main code inside the main body of if because we want it to be longer than 2 characters, otherwise it's not really going to be a meaningful palindrome program. Okay, so that's the first couple of points out of the way really easily. My third point about using variables, we have used one variable already, we'll use more I'm sure. And the second bit here about meaningful names, this is to say, you know, your variable should be the name should give you a clue as to what it does, because it's really hard, as you may know from experience, looking at someone else's code, first of all trying to figure out what's going on, but also that's made much worse if they've just used stupid variable names and given it, names of their buddies and so on. So it's a good idea to try and keep it relevant. I mean, here text doesn't tell you too much, but I think it would help you figure it out. You could be more specific. You could be text to check palindrome, but it just gets a bit too long and it defeats the point a little bit. So we'll kind of say we've accepted that, but we'll keep watch for making sure it's meaningful. Now we want to be able to use a string handling operation to reverse the input. Now the best way of doing this is with string slicing. So string slicing is where we want to get a substring out of one of our strings, and we do this using, so if we have text, we'll do this using square brackets, and we can put different indexes. So if I want to get index 0, if I want to start maybe index 2, go towards the end, and we could just print this to see what's going to happen. So if I enter something like, let's do racecar as one word, it's going to just get rid of the first, it's not going to show the first 2 characters because we're starting at counting at index 2. Remember, programming always starts counting at 0, and so we've got 0, 1, 2. We start counting at C. So that's string slicing, but we can also use string slicing to reverse it. And we have a third parameter in this sort of indexing operation, which is our step size, really. But if we put a negative step size, a -1 here, what it's going to do is reverse it for us. So if I again type in racecar, this time we're going to have it reversed like that. It doesn't look like it's reversed because it's a palindrome. If I do a different example, if I do hello, we should get olleh as we'd expect. And let's just check our conditions work. If I just do hi, we should get it to be, it shouldn't let us move forward. Okay, so we've reversed the input, but I haven't really communicated to the user as my next one asks for. So if I just edit this print statement, I could say your text reversed is, and then end off this string, do a comma because it's separate. It's a separate object to our then reversed text. The comma, remember, is going to add a space for us, which is quite nice. We can also add a colon on here, maybe makes it a little bit cleaner. So it's a bit more communicative to the user. We have already used if and else, so we can remove these criteria as well. And now we need to add a few comments. We haven't done our second stage of our program yet. We haven't actually done anything to do with palindromes yet. But if I just add in a comment, up here we are checking length of input. And down here I might want to say must be greater than 2, so program ends. Now these comments are not necessarily particularly useful, to be honest, but in proper programs, a bit like how your variables should be meaningful, without comments it becomes really, really hard to understand what's going on. Some programs are so confusing that actually you need a bit of help via comments. So here we could say we are using the step size value as -1 to reverse the string. Alright, so let's extend our code to actually make it into a palindrome checking program now, which we sort of have got the main work for us, because really we're just checking to see if the original string is the same as the reverse string. Racecar was, hello wasn't. So again, we're going to have another if statement nested inside this other if statement. We need to make sure our indentation is kept consistent, because this if is going to belong inside this if, and you can see the indentation, the little gap, shows us that it is the case. So if I do another condition here, I want to see if our text is the same as our reversed version of the text. So exactly the same string slicing operation again, and this double equal sign is allowing us to actually compare the two sides as opposed to seeing if one is greater or less than the other. And if they are the same, it is a palindrome. Your text is a palindrome, like so. And if it's not, else covers all other cases. We could do elif and do text not equals the reverse text, but actually we can just do else because it covers all other cases. We could say your text is not a palindrome, like that. We could run this just to check this works. So racecar should be a palindrome, which it says it is, perfect, whereas hello shouldn't be. So one thing which could throw a spanner into the works of our code is if I type in racecar with a capital R at the start, we're going to get told this is not a palindrome, and I realise now it says your nothing is not palindrome, your text is not palindrome. But the issue here is, I think a human would say, well, this is a palindrome because the capitalisation doesn't really matter. But to a computer, capital R is totally different to lowercase r. They have different codes inside the computer, and so that comparison is failing because they're not the same. But actually we want them to be treated the same, I would suggest. So what you can do here is make sure you are standardizing your input. If capitalization doesn't matter, you can make sure all of your letters are going to be all lowercase or all uppercase. So what I would do right at the start here is, after I've got the user input, I can just convert whatever input this is to be all lowercase or all uppercase. So I'm setting text again to be the old version of text, but I'm now going to call a method on this, a string handling method, which will do this function for us, and this is called either lower or upper, which makes it lowercase or uppercase respectively. So I can try this again, and if I now type in racecar, it should get, we are being told it's a palindrome because it's ignoring that capitalization. However, it looks a bit weird because we've got in some text racecar, then it's reversing it, but it's making it all lowercase, so it's not quite reversing it, it's converting it for us. So actually you may want to set this variable up here to be something called maybe standardized, again having meaningful names, and then we can leave this version of text down here, but let's just copy and paste the standardized version down in terms of our actual comparison, because that's what we care about, the standardized version behind the scenes, but the user can see that original bit of text. So hopefully this works. Yep. And above line 2 would be a good place to add another comment, just saying capital letters don't matter, so all text is converted to lowercase. Okay, so that's our sort of basic core requirements done in a fairly short program here, although a few potentially tricky bits, right? Mostly dealing with the string handling and also using the selection and having nested selection as well if you want to exclude all text shorter than 2 characters. But now let's try and get this to work with phrases, because that was one of my extension bits as well. So do geese see God is an example of a phrase palindrome. So we're getting told this is not a palindrome because we have issues here, right? Well, the capitalization we've sort of fixed, but we also have the punctuation here, which is going to cause some issues because the question mark is not at the start, but it is at the end. So what I could do to address this is kind of assume my last character is always going to be punctuation, like a question mark or a full stop, and just remove that last character. Now, I mean, there are issues with this, right? Because not only is not all punctuation always at the end, but also if you haven't got punctuation, you're going to remove your last character. If you did want to go down this route, you could use a slicing operation like this. We're starting off at the 0th index, which we can leave off or include if we want to, then our colon, and then our last index is going to be the last one. So the minus 1 index is our last character, so in this case the question mark. But the way Python slicing works is we're counting up until that point, so we're not including that second index applied. And so this should, if I just print out standardized, and also why don't we print out the reversed version of this as well, just to see it. We should get rid of it, but there'll be some issues as well, as we'll see. So let's try this. So even when we're sort of typing in the case expected here, we have punctuation at the end, like question mark. It is working because it has removed that question mark, but you can see the reversed version is clearly not the same as our original version because we haven't got the spaces also need to be removed. But anyway, let's come back to that because this is not really a good solution, because if you typed in anything else, if you typed in let's run this again. If we typed in race car without punctuation at the end, it's not going to work because it's removing that last character. So let's remove these lines from this sort of slightly naive attempt, which it's worth a go. You definitely programming won't get things first try. So let's instead find another way of removing punctuation. Now I haven't taught how to do this because it's kind of like there's not much point teaching everything, or it'd probably be impossible to teach everything because there's so much. Python's been around for a long time now. So really the solution is, when you are programming, is to look things up. There's no harm in looking things up. Lots of exams nowadays at university level allow students to look things up during programming assessments because it's unrealistic to learn every single function. It's just not how things work in real life. So if I've just googled here remove punctuation Python, I'll get lots of responses, and choosing the correct place to look can be a skill in and of itself. If you are quite knowledgeable, you can just look straight at the documentation which Python develops, but a lot of that isn't designed for, newbies, I suppose. So this website, Stack Overflow, crops up a lot, and again, this is not necessarily designed for newbies either, but people can ask questions and there'll be answers to solve the issue they're having. And these are the answers here are from 2008, so it's likely your question has been answered by someone else, as it has here. So you've got to read a little bit carefully, and you'll see, as probably a beginner at this point, lots of code doesn't make much sense right now. But we have got an answer to our question down here. It says, for higher version of Python, use the following code. This line above wouldn't work because this is for Python 2. We're trying to do Python 3. So this line here, where we use a built-in function called translate, will do the job for us. So we can just copy and paste this. We've got to be careful, doing this. It can become a bad habit. Certainly as a teacher, I see so much copy and pasted code without any attempt to change it or understand what's going on. So, someone will just put this in and leave it. Of course, you've got to change it, right? So we've got to incorporate this into our code. So we've got standardized. We want to now, with mid lowercase in line 3, we want to now remove all punctuation, and we can use this line of code. This S is our variable we're doing it on, so it's standardized. And what translate does is, as it suggests, takes one string and puts it and converts it into another string. The actual arguments here, because we have str, our data type string, it's got another method called makeTrans, and we have now 3 different bits of data going on, 2 empty strings and then string.punctuation, which is a lookup table. So the way this works is really, it's looking up all the punctuation. Actually, why don't we just print string.punctuation and try that, except we're going to have an error, but let's just see what the error says first of all, because in fact we've got to do this first. So we get a name error. It says name string is not defined. So in this line, string.punctuation, string is not defined. It's expecting string to be a variable or an object, but it's not yet, and that's because we need to actually import what we call a library or a module called string. And actually, that's one of the issues with maybe using online sources. It doesn't actually say here you need to import string, so a newbie can get a bit confused, which is why this is an extension task. So we've imported string, and now we can print this again. I should have really put this before my enter some text bit, but here we can see on this line, ignore the other lines, the punctuation in this lookup table, and none of these we want in our actual palindrome. So let's just remove line 7, or comment it out at least. That's always quite useful, and uncomment line 8, and let's see how this does. Let's have a look at what this does so far. So enter some text. Let's do racecar with an exclamation mark at the end, and it says it's a palindrome. So now we have removed this issue with punctuation, and it's working better. But still, if we have, say, if we run this again and do it with a phrase as opposed to a single word, so do geese see God and have our question mark. The question mark won't be an issue, but the issue is going to be the spaces, because the spaces are causing it to not be equal forwards and backwards. By the way, just before we move on to that, if you do use a source from online, like I said, it can quickly become a bad habit if you do this too often. Personally, I do it fairly often, right? I think most programmers do. I didn't know how to do this, I had to look it up myself. But it's always important to reference where you got it from. So this was answered by Brian, so it's not the most useful name, but in terms of, lots of Brian's about. So source Brian from, and we could give a link, couldn't we, to this article, just to make sure we're not using someone else's work without credit. If you do, if you submit any assignments to, say, school or university without giving credit, it can put you in lots of trouble for plagiarism. So actually I do know how to do removing spaces. That's a little bit more common. I haven't actually ever had to remove punctuation before, I don't believe, or not that I can recall, but spaces, yes. Here we can use a method called replace. So again, in a similar sort of way, standardized, and we want this to be now replace, following our dot, and we have 2 arguments here. The first one is what we want to replace. So here we want to replace a space, and a space is in a string with the 2 quotes is just a space on your keyboard. So we have 1 space here, and we want to replace this with nothing, so we show this with an empty string. So here there's there's nothing in between those quotes. Here we have got a space, even if it's not incredibly obvious unless you look closely. So hopefully now if we try this again for, I don't know how many times we've done this now, do geese see God, we should finally get what we want, which is your text is a palindrome. So we've done some pre-processing, made it lowercase, removed punctuation, and removed those spaces. So that was our first of 3 extension criteria. Well done if you managed to do that. It required some initiative and possibly some trial and error in doing that, so well done if you did. Our second one was about printing out, so instead of saying your text, we're saying it's going to be either a string or a number. So your number is a palindrome. So here, if I, well, maybe stating the obvious here, if I do 1, 2, 3, 4, this isn't a palindrome, but it's not going to say it's not a palindrome number. So this will happen further down because we're doing our evaluation of it forwards versus backwards down here in this if statement. So we want a third nested if statement within this second one, because once we've checked if it is a palindrome, we want to then check if it's either a number or a string. There are a few different ways we can do this. The one I'm going to show you is not the most perfect way of doing it. It has issues because, well, actually, does it have issues for this purpose? Perhaps not. I'll explain more in a second. So what we can do is use another method, which I haven't taught again, you'd have to look up, called isDigit. And what this is doing is checking this, what is currently a string. So whatever we have in standardized so far is just a string, because by default, all input is a string, even if it looks like a number. And we haven't made any effort to cast this into an integer. So it's going to check it, see if it's an integer, and isDigit returns true if all of the values in that is an integer. It won't work with floats, it won't work with negative numbers. So there are some limitations, but maybe not for this purpose. So if I compare this, so whatever this is it's either going to be true or false. We want this to be, so if this is going to be true, we're then going to print your number is a palindrome, because we know it's a number, or an integer to be more specific. We could say your number is a palindrome, and else we're going to say, well, it is a string. Instead, we don't need to do another condition because else covers all other cases. Here there are only 2 cases because isDigit is going to return either true or false. So here your string is a palindrome. So fingers crossed, if we try this it should work. So what was the one I give? So 1, 2, 3, 2, 1 should be a palindrome. Except that I forgot that isDigit should be all lowercase. I will forget these things. And so let's try this again. 1, 2, 3, 2, 1 should now work once I correct my code. So yeah, your number is a palindrome. If I try racecar again, which should be your string is a palindrome, let's see if this works. And it does as well. We did have a third optional extension, which was to make it into a function. I won't show you this because actually it's not too hard once you know how to do it, but that'll be covered in a future video. So that covers this challenge. Hopefully you tried it yourself and had a good go at it. If you didn't manage to do everything, that's absolutely fine. Like I say, I like to lift things up. I made some mistakes doing this, so that's okay, definitely okay if you did too. So if you have any comments or questions, please let me know. Otherwise, thank you very much for watching.